Hello, and thank you for joining me for this internal discussion on the concept of connecting the Hach DDS data delivery service to XPSWM. My name is Adam Rose, and I will be giving the talk. So let's go ahead and get started. The first thing I'll do is actually log into the development side of Hach's data delivery service. And so I'll just press login, and hopefully I'll be brought up with the dashboard. So this is in the Portland area, and you can see it's brought up on this Hach Laurel meter, and this is a flow meter. It's currently got an alarm on it. If I go to server alarm, it said missed a call, so it hasn't transmitted data recently. The last call was 4 days ago, but that's okay because we're just showing the idea of what you can do. There are no instrument alarms. In other words, there aren't any alarms set to say actuate if there's a surcharge or an overflow. It's just that the instrument itself is down. You can see the different data you can get: power supply, rain if that's enabled, level, which is in inches. You see velocity, flow, temperature, surface velocity, surge level, some diagnostics. So lots of data there in this map view. You can also get that in tabular, graphical, or spit out some reports, and you can kind of zoom around and see other data. So it's really quite a nice system. It's quite a nice product. And you can do a lot of things with this data looking at it here. There are also some utilities to export this data out in flat file, like a CSV or Excel. And a lot of people do that. They take this data, this real-time data. I mean, if this is on and active, it's real-time data to every, say, 15 minutes. So it's real-time data, but oftentimes people take that data and just copy it locally at a random time and then merge that into their Excel file or their hydraulic model. And while that's a straight ahead workflow and easy enough to set up, it's really nice to be able to actually leverage the real-time ability of this by putting it directly in a software product. So we're going to go ahead and do that with XPSWM. We're going to take this data and interface it directly with XPSWM. And let me give you a little bit of background on how we're going to do that. This data is available obviously through HTML. I can look at it here. It's also available through the SOAP protocol. And so there are two main protocols for getting data, either a RESTful protocol or SOAP. And Hach has a SOAP protocol, and that was provided to us. And our development team took that protocol and wrote a simple executable. And so let me show you what that looks like. If I look at my directory here, it's called XPFS data, and it automatically shows you the help. So you can see here, if I type that in and I give it the request name, in my instance I'd want get site measurements, and I tell it the site number and the last time I want it to get data, where to put the file, and if I wanted to copy the request or not. If I run that, it will go ahead and collect data. So every time I run that file, it will collect the data and return it in XML format, which is great. So that's a pretty straightforward way of doing it. All I did was take this utility and wrap around it some logic to be able to collect only certain times and dates. In other words, if I collect data now and I re-request in an hour, I should only be requesting the last hour's worth of data. There's no reason to collect more data. So some logic to do that, and some persistence to store that kind of information, as well as some utilities to convert the XML to row column data. So we'll convert from XML to something more like a CSV, but we'll just be doing that as an easier way to get the data into SQLite. So we'll store all the data in a single database, and that's really useful because the data we want to get out of it can just be table views on that database. So we'll get table views, and we can export those out as CSVs quite easily, and CSVs can be read again directly into XPSWM. So you may say, well, there's kind of an extra step there, Adam, but getting the data from XML to CSV to SQLite makes it really powerful. We can use it not only in XPSWM, but we can use it anywhere. I think there's value there, and you can see it runs quite quickly. So the other file that actually wraps all this in is something I just called get data. So let me clear this so you can see what it does. So if I say get data and run that, and you can see here it says it's sending a request to the server. So it's based on the time. So it picked a time behind when this one went down, and this actual Laurel gauge. And so it's sending a request using that protocol and asking for a specific amount of data back. And that is usually pretty quick. It just depends on how fast your internet connection is. And you can see here, completed it. It got all the site measurements, and so it pulled that back, and then it converted the XML data into CSV, brought it in the database, and then created the table views. So pretty quick. The longest duration, of course, is to get the data off of the remote server. Everything local is really quick. So let's take a little look about what we created. I'll start with the database and kind of move backwards from there. So if I look at this, this is a really simple way to view data. Look at this database here. You can see this output table. And let me make this bigger so you can see it. I just have a few columns. There are many more columns of data that could be received and actually were received, but I only grabbed the time it was downloaded off the server and then the actual timestamp here. And this is directly from the output in a timestamp. And then you'll see this data type and then a value and then a value null. There's two different values that are coming back. Data type, let me pull that up real quick. If I open that up, you'll see in my testing, let's see, measure values. So the different type have different descriptions. So 7 is level in inches, 11 is velocity, and 15 is flow. And so if I go back here, so this 7 is inches. So at this timestamp, that is the value in inches. So it's all the data here, so 363. And I just have real simple table views. So I can look at this, and it just says create a view, format it the way that XPSWM is going to want to see it. And in this case, just to show an example, run a little bit of post-processing to turn that depth into an elevation. Same thing for flow and velocity. So those are dynamically generated. Anytime new data shows up here, these are updated. Simple enough there. And then if I go look in my actual output, I can output those as actual CSVs. So that elevation file, see if I can open that up so you can see it here. If I make it bigger, it's all the same site number, so you notice that I could be pulling lots of sites at the same time. This doesn't have to happen independently for different sites. The date, the timestamp, and the level. So let me close that out. I'm not going to save changes. So what can we do with that? Well, again, you see the data in this format here. Let's bring it into XPSWM. So let me show you. There's a dot here, kind of in between Portland and Beaverton. By no means do I have the sanitary sewer system in the area. This is just a complete guess, but that's roughly in the same area, that dot. So and I named it the same thing, 3126. And so there's a couple different ways I can get data into XPSWM. One way is using this gauge data, and this is for comparative purposes. So in this case, I have a gauge level, and I pointed it to that elevation.csv file, the file we had before. I could specify the station name if I needed to, 3125, although unnecessary in this case because there's only one. And then I've user defined that format as elevation. And if I look at that, there's the first field, which is the station, which, because I'm using one, I just left as a dummy, date, time, and elevation. So that's how I'll parse my data. And sure enough, if I hit edit, you can see the same data we saw in the CSV file. Again, know that every time I run this, it will actually get the data. And I suppose I should specify when I say run this, I mean run that executable. In other words, whenever I run that get data, it will automatically put all the logic together to put the most recent data in there. So let me close out of this. That's one way that you can compare data. And I notice here that I named this incorrectly, so that actually should be 3125, not 3126. So I could change that if I wanted to and call that 3125, just to be consistent. And then we'll call this 3124, let's say. Okay, but let's say that I had the gauge data from 3125 and I wanted to use it to actually run the model. Well, you could do that as well. You can actually have the flow itself. So recall on this 3125 we use gauge data to put in the level. You can actually also use it to put in the flow. So it's very similar. So we have station 3125 and the flow.csv, and then we have a flow parser instead. So if I look at that one instead of elevation, very similar except for it has flow and GPM, and XPSWM can handle the conversion. So what I can do then is run this model. I'll solve it. It'll solve pretty quickly. I set it for the same time duration as when this data was, so in June 2014. And what I can do is actually look at the results. And so let's take a quick look, and what you'll see here is a couple things. One, you see the gauge depth. So in other words, this here, this solid colored line, is actually what the gauge in the ground showed during this time period in June 2014. So that's actual data for comparison purposes. I also took that same data and put it in the model to run the model. So you can see one spot there where I probably post-process out. That's a 0 when we know that in fact there was probably flow. So we have no flow, so the model is going to show, of course, no depth. And we have a little bit of instability at the very beginning of the model that could be removed with the time step. Again, the point here isn't to calibrate this, but just to show you, if I have a model, I can have the actual data. And so every time I were to rerun that, you would see this line continue to grow. And it just depends on how often you want to do it. XPSWM has ways of launching applications, so I could easily go in here and say have something called real-time data, where if I click that, it automatically ran the executable, the batch or command or other file, directly from XPSWM. And that can be quite useful, and it just depends on how often you're running the data. The other thing you can do, I guess there's two other things you could do. You could have something like that set on some type of recurring task, so you could use Windows Task Scheduler to run that, say, daily. Let's say every day at 12 o'clock in the afternoon, you set a task to go ahead and query the last 24 hours worth of data. That's one way to do it. The other way you could do it, depending on how often you're returning the data, is set up something on, say, a local instance. So this is just running locally, and it says I've collected data as of whichever time. It's not live, but if I click this restart button, it'll go ahead and itself execute the file, and then if you set a timestamp, it will just sit and run as often as you like. So it's querying the same data we queried, but by way of a local host instead of through the batch file, although it's the same program. And here you can see it's set to every 5 minutes it'll refresh. And so this is actually something I can run on a thumb drive, so I can just plug it in and have it run, and as long as it has internet connection, it can go query the data however often I want. So I don't really have to go through the task scheduler if I don't want to. It's the same idea, just different places to do it. And I chose to put the flow in the upstream manhole, not in the same manhole. There would be some attenuation there, and that attenuation would continue down the model, which is part of the reason you'd have a model. So I could look at results just as much here in the downstream node as the upstream node. And I know that unless there's infiltration or something occurring between the two nodes, this is what the stage curve should look like during this time frame for this node based on actual data. And depending on how often I'm refreshing the data, real-time data. So that's the summary of what I wanted to talk about here, the concept of getting the value of real-time data as a service, and putting it directly into a model that has high analysis value. So that's the end of what I had today. I think we were at about 15 minutes. The purpose here wasn't to generate anything extra fancy or polished, but just to show the beginnings of what could be a nice mutual benefit, taking the real-time data and the analysis. Right now we're using some extra tools to keep everything real time, and they run quite well. Obviously there could be some efficiencies gained in the way that the two programs interface. This was just to show what could be possible. I appreciate your time. Thanks.